All right, so get this. You send us some research about a possible new planet,
Oh, wow.
a planet X in our solar system.
I know, right?
Hmm,
It's like straight out of science fiction.
it is.
But here's the thing. It's based on some pretty solid science.
Right.
So today, we're diving deep into the world of trans-Neptunian objects.
Okay.
These icy bodies way out beyond Neptune to see if there's really something to this Planet X idea.
Yeah, what's really cool is that this whole idea of a planet X has been around for ages.
Yeah,
You know, astronomers have been searching for this mysterious world since like the 1800s.
I know. There have been so many false starts and like tantalizing hints over the years. It's like a cosmic treasure hunt.
Mhm.
Remember the whole Planet Nine buzz a few years back?
Yes, that was quite a saga.
It was.
Brown and Badigan presented some interesting evidence based on the way some objects in the Kuiper Belt were clustered together.
Right.
But it was controversial, and the search for Planet 9 hasn't turned up anything conclusive yet. So where does that leave us? Well, this time we're looking at a brand new study by Siraj, Chiba, and Tremaine, published just this month.
Okay.
These scientists are taking a fresh approach, and they're focusing on the long-term stability of these trans-Neptunian objects, or TNOs, to try and find clues about a potential planet X.
And that's key here looking at the long game, because if there's a planet out there, its gravitational influence would only become apparent over billions of years.
Hmm.
You need to look at objects that have been around long enough to feel that pull.
Okay, so we need to understand how these TNOs behave over vast stretches of time. And in this study, they've actually categorized these TNOs as unstable, metastable, or stable. Can you break that down for us?
Imagine you're throwing a frisbee in a park, but there are these random gusts of wind.
Yeah.
So the unstable TNOs are like a frisbee caught in a crazy windstorm.
Okay.
They could get flung right out of the park, or in this case, the solar system. Metastable ones are more like they're in a gentle breeze. They might wobble around a bit, but stay within the park. And then you've got the stable TNOs. Those are like throwing a frisbee on a perfectly calm day. Their orbits are nice and steady.
Okay, I can picture that. So why is this distinction so important in the hunt for Planet X?
Because only those stable and metastable TNOs would have been hanging around long enough to be nudged around by a possible Planet X. Their orbits are the ones that would tell the story.
So those are the ones we really need to pay attention to.
Exactly. And what's fascinating is this study goes beyond just looking at the basic shape of those TNOs' orbits.
Okay.
They ran super detailed simulations to classify them.
Wow.
And that's where things get really interesting, because they found that some TNOs we thought should be unstable are actually quite stable.
Interesting.
It means our assumptions about what makes a TNO orbit stable might be a bit off.
Oh, that's kind of like realizing that maybe the wind in the park isn't as predictable as you thought.
Right.
So what does this all have to do with finding Planet X?
Well, if a Planet X is out there, it would act like a gentle, persistent gravitational tug on those stable TNOs. Okay.
And this tug would cause a specific type of clustering in their orbits.
Clustering. What do you mean by that?
Think of it this way. Imagine drawing a line from the sun to the point where a TNO is closest to the sun in its orbit.
Okay.
That's called the perihelion. Now, imagine you draw those lines for a bunch of stable TNOs.
Okay.
If there's no Planet X, those lines would be pointing in all sorts of random directions,
Yeah.
like a messy starburst.
Okay.
But if Planet X is out there, those lines would start to bunch up and point in roughly the same direction.
So it's like a hidden hand is aligning them.
Precisely. And that's exactly what they found. This clustering of stable TNOs perihelia, but only for the ones beyond 170 AU.
Hold on. 170 AU. Even I know that's ridiculously far out there. That's like 5 times farther away than Neptune.
Exactly. And here's the kicker. They didn't see this same clustering for the unstable TNOs. And that's huge, because it tells us this isn't just a fluke of how we're observing things. It means there's likely a real gravitational force out there influencing those stable TNOs. Okay, I'm starting to see the pieces come together here. But how do we go from this clustering to figuring out what this Planet X might be like?
That's where things get even more intriguing. They used computer simulations, like a giant cosmic sandbox, to model different scenarios. They threw in a hypothetical Planet X with different masses, orbital shapes, and tilts, and they watched how it affected those virtual TNOs.
So they're essentially running experiments on a planetary scale.
Exactly. And here's the exciting part. The simulations that included Planet X matched the real-life clustering of those stable TNOs much better than the simulations without it. It's like finding a perfect match in a cosmic fingerprint database.
Okay, now I'm really hooked. So what does this tell us about Planet X? What might it be like?
Well,
Whoa, that's almost 10 times farther than Neptune. We're talking deep space here.
oh,
What else do they think they know about it?
they estimate that its orbit is a bit oval-shaped, not perfectly circular, and it's tilted at about 6.8 degrees compared to the plane of the solar system.
Hmm.
Importantly, they found a strong connection between some of these characteristics.
Meaning.
It tells us we're not just looking at random possibilities here.
Okay.
It narrows down the search area, giving us a better idea of where to look.
So it's not just somewhere out there, but a much more specific, if it exists, it's probably in this region of space. This is like they've given us a treasure map.
Exactly. And you know what? This treasure map points right to where the new Vera C. Rubin Observatory will be looking.
Oh, really?
They're about to start a survey that will scan the entire southern sky and detect objects way fainter than we can see now.
Wait, are you saying that we might actually be able to see this Planet X?
It's possible. This new observatory is going to be a game changer. It's going to spot tons of TNOs and either confirm this clustering effect or make us rethink our theories. Either way, we're on the verge of some major discoveries.
Wow.
Yeah, it really makes you wonder what we might find out there, doesn't it? This research is like a preview of what might be waiting for us.
I know. And you mentioned this new observatory is going to spot a ton of new TNOs, but won't that just make things more confusing? I mean, more objects to track, more data to analyze. How does that help us find Planet X?
That's a great question. It's true that more data can sometimes make things seem messier at first, but here's how it helps.
Okay.
Remember how the researchers found that statistically significant clustering in those stable TNOs orbits?
Yeah. That was their big aha moment.
Right.
Like those lines from the sun to the TNOs were all pointing in the same direction.
Exactly. Well, with the new observatory, we'll be able to see if that pattern holds up as we discover more and more TNOs. If it does, it makes the case for Planet X even stronger.
But what if it doesn't? What if we find a bunch of new TNOs and their orbits are all over the place?
Well, that would definitely make things interesting.
It would.
It might mean that the clustering we're seeing now is just a coincidence, or maybe there's some other factor we haven't considered yet.
So this new observatory is kind of like the ultimate test.
It is.
Either it strengthens the evidence for Planet X, or it sends us back to the drawing board. Either way, it's going to be exciting to see what it reveals.
It's like having a brand new, super-powered telescope pointed at the most mysterious part of our solar system. We're bound to learn something amazing.
Speaking of amazing, you know what really struck me about this research? They were so careful about making sure their Planet X didn't mess with the TNOs we already know about, especially the ones that are in a special kind of bands with Neptune.
You mean the TNOs that are in resonance with Neptune?
Yeah, that's the one. Is resonance like a cosmic tango?
It's more like a precisely choreographed orbital ballet. It means that the orbital periods of two objects, in this case a TNO and Neptune, are related in a simple ratio. So for every few orbits Neptune makes, the TNO makes a specific number of orbits, and they stay in sync.
So it's like they're moving to the same cosmic beat.
Exactly. And these resonances are actually quite common in the solar system.
Okay.
It's how gravity keeps things organized.
So how did the researchers make sure their Planet X wouldn't step on Neptune's toes, so to speak, and mess up this cosmic dance?
They ran more simulations, but this time they focused on these resonant TNOs.
Okay.
They wanted to see if their proposed Planet X would kick those TNOs out of resonance, like knocking them off beat.
And what did they find?
Thankfully, their Planet X seems to play nicely with the resonant TNOs. The simulations showed that those objects would mostly stay in their stable orbits, even with Planet X's influence.
That's good news. It means their model fits with what we already know about the outer solar system. It's like they checked their work and made sure everything added up.
Precisely. And that's what makes this research so compelling. It's not just a wild idea, it's a carefully considered hypothesis that takes into account all the complexities of the outer solar system.
Okay, so we've got this clustering evidence, we've got the simulations that back it up, and we've got the fact that it doesn't conflict with what we already know about resonant TNOs. That's a pretty strong case for Planet X, wouldn't you say?
It's certainly building a compelling argument, but remember, in science, we never say anything is 100% certain. We're always open to new evidence and new interpretations.
Fair enough. So let's say, for the sake of argument, that Planet X really is out there. What would it be like? I mean, what kind of world could survive in that cold, dark corner of the solar system?
Now that's where we can let our imaginations run wild, guided by what we know about planetary science.
All right, let's take a trip to Planet X. What would we see as we approached it?
Well, first of all, it would be incredibly faint. Remember, it's about 10 times farther away from the sun than Neptune, so the sunlight out there is incredibly weak. We might need some serious night vision goggles.
Got it. So a very dim world. But what about its size and shape? We know it's estimated to be about 4 times the mass of Earth.
Right, so it's definitely not a small, rocky planet like ours. It's probably a super Earth or maybe a mini Neptune.
Okay. I think some of our listeners might need a refresher on those terms. What's the difference between a super-Earth and a mini-Neptune?
A super Earth is basically a bigger, heavier version of our planet, still made mostly of rock and maybe some metal. Think of it as Earth's big brother.
And a mini-Neptune?
That's like a smaller, less massive version of Neptune. It would still have a thick atmosphere, probably made mostly of hydrogen and helium, like the gas giants. And it might have a rocky core surrounded by a layer of ices, like a giant slushy.
Okay, I'm starting to get the picture. So which one is our planet X more likely to be? A supersized Earth or a mini-Neptune?
Given its mass and its distance from the sun, a mini Neptune seems more likely.
Why is that?
Well, think about it. It's so far away from the sun that it would be incredibly cold. A rocky super Earth might not be able to hold on to much heat. But a mini Neptune, with its thick atmosphere, could act like a giant blanket, trapping some of that internal heat.
Ah, I see. So if we could get close enough to see it, it would probably look like a dim, bluish world shrouded in clouds, kind of like a mini Neptune.
That's a good way to imagine it.
But hold on, if it's a mini Neptune with a thick atmosphere, would it even have a solid surface?
That's a great question, and it's one we can't answer for sure without more data. It's possible that its atmosphere just gets denser and denser as you go deeper, eventually blending into a giant, high-pressure ocean, maybe even made of exotic forms of ice.
Wow, that's wild. So no chance of landing a spacecraft on Planet X, at least not with our current technology.
Probably not, but hey, who knows what the future holds? Maybe one day we'll have probes that can dive into those extreme atmospheres and explore those hidden oceans.
I'm already picturing those headlines. Scientists discover giant slushy ocean on Planet X. Okay, maybe not the most catchy headline, but you get the idea.
I can see the news report now, but for now we're still in the realm of speculation, but it's fun to imagine, right?
Absolutely. So we've got this possible mini Neptune shrouded in clouds, maybe with a giant slushy ocean underneath. But here's another question that's been bugging me. What about moons? Could Planet X have its own little family of satellites?
It's certainly possible. Lots of planets in our solar system have moons, so there's no reason to think that Planet X would be any different.
And what would those moons be like?
Well, again, we're just speculating here, but they could be incredibly diverse. Some might be rocky, like our own moon, while others might be icy, like some of the moons around Jupiter and Saturn, and some might even have a mix of both, with rocky cores and icy shells.
And wouldn't those moons also play a role in the whole gravitational dance of Planet X's system?
Absolutely. Remember how we talked about those resonant TNOs?
Yes.
Well, moons can create their own resonances within a planetary system. Oh.
They can influence each other's orbits, create tidal forces, and even generate heat within their interiors.
So finding Planet X might not be just about discovering one new world, but a whole new system of celestial objects, each with its own story to tell.
Exactly. It would be like opening a new chapter in the story of our solar system.
Okay. I'm officially hooked on this idea, but, as we've been talking about this new research, I can't help but think back to the whole Planet 9 theory. What are the key differences between this new Planet X and the one proposed by Brown and Badigan?
That's a great question. There are several important distinctions that make this new research stand out. First of all, their approach to classifying those TNOs was much more thorough.
You mean how they used those detailed simulations to figure out which ones were truly stable?
Exactly. Brown and Badigan relied on a simpler method that just looked at the closest point of a TNO's orbit to the sun. But this new research took into account all the complex gravitational interactions that can affect a TNO's orbit over billions of years. So it's like they had a much more sophisticated understanding of those cosmic wind patterns we were talking about earlier.
That's a great analogy. And because they had a better way of identifying stable TNOs, they were able to include a much larger sample size in their analysis.
Which gives them more statistical power, right?
Exactly. They used data from 51 TNOs, while Brown and Badigan only used 11, so they had a much bigger data set to work with, which makes their findings more robust.
I'm starting to see why you're so excited about this research. They really did their homework.
They did. And there's another key difference. Brown and Badagen were looking for clustering in multiple orbital elements, but this research focused specifically on clustering in the longitude of perihelion.
Okay, remind me what that is again.
It's basically the direction that a line from the sun to the TNO's closest point to the sun is pointing.
Okay.
And it turns out that this specific element showed the strongest evidence of clustering.
So they zeroed in on the most telling clue, the one that pointed most directly to planet X.
Exactly, and because of that, they were able to come up with a more refined estimate of what this planet might be like. Their planet X is less massive than the one proposed by Brown and Badagen, and it's orbiting closer to the sun.
So it's a smaller planet on a tighter orbit. Interesting. But even with those differences, it seems like both teams are pointing to the same general idea. There's something big and unseen lurking out there in the outer solar system.
Right, and that's what's so fascinating. We have two independent research groups using different methods and different data sets, but both arriving at a similar conclusion.
It's like they're both seeing the same shape in the cosmic clouds, even though they're looking from different angles.
Exactly, and that convergence of independent research is one of the most powerful things in science. It tells us that we might be onto something truly remarkable.
Okay, so we've talked about the research, we've imagined what Planet X might be like, and we've compared it to the Planet 9 theory. But there's still a part of me that's wondering if this is all too good to be true. I mean, it would be incredible to find a new planet in our solar system, but could it be a case of wishful thinking?
That's a healthy skepticism to have. It's important to remember that science is a process of constantly testing our ideas against the evidence. And while this research is certainly exciting, it's not the final word.
So what would it take to really confirm or refute the existence of Planet X?
Well, as we've discussed, the Vera C. Rubin Observatory is going to play a crucial role. The data it collects over the next few years will either strengthen the case for Planet X or suggest that we need to look for another explanation.
So we need more data, more observations, more evidence.
Exactly. But that's what makes science so thrilling. We're constantly pushing the boundaries of our knowledge, and we're always open to being surprised.
Speaking of surprises, you mentioned earlier that the researchers went to great lengths to make sure their Planet X wouldn't disrupt the stability of those TNOs that are in resonance with Neptune. But what about the possibility that Planet X itself is in resonance with another object in the solar system?
That's an intriguing thought, and it's certainly possible. In fact, resonances are a fundamental part of how our solar system is structured.
So if Planet X is in resonance with another object, what could that tell us?
Well, it could give us clues about its formation and evolution.
Okay.
For example, if it's in resonance with Neptune, it might suggest that they both formed in the same region of the early solar system and migrated outward together.
Or maybe there's another, even more massive object out there that we haven't detected yet, and Planet X is in resonance with that.
Now, that's a tantalizing possibility, and it highlights how much we still don't know about the outer reaches of our solar system.
That's like there's a whole new chapter of the cosmic story waiting to be written.
Exactly. And who knows what other surprises might be lurking out there in the darkness.
Well, on that note of cosmic mystery, I think it's time to wrap up this part of our deep dive.
Agreed. We've covered a lot of ground today, from the details of the research to the hypothetical characteristics of Planet X and its potential moons.
But before we move on, I just want to remind our listeners why this research is so groundbreaking. It's not just about finding a new planet. It's about expanding our understanding of the solar system and our place in the universe.
Well said. It's a reminder that we're still exploring our cosmic backyard, and there's still so much to learn.
It really makes you think, as we're talking about this potential Planet X.
It does.
And the idea that it could be in resonance with another object out there. It makes you think about how much we still don't know about our own solar system.
It's humbling, isn't it?
It is.
We often think of our solar system as this, familiar, well-mapped territory. But the reality is that there's still these vast, uncharted regions out there, full of mysteries waiting to be uncovered.
It's like we've only just begun to explore our cosmic backyard. And this research is a reminder that there could be entire worlds out there, hidden in plain sight, just waiting for us to find them.
And who knows what those worlds might be like. We've already speculated about Planet X being a mini Neptune with a giant slushy ocean, but the possibilities are truly endless.
Okay, let's indulge in a bit more cosmic speculation. Let's say we do find this Planet X, and it turns out to have a system of moons. What kind of moons could we imagine out there in that cold, distant realm?
Well, I think we can draw some inspiration from the moons we already know about in our solar system.
Okay.
We've got icy moons like Europa and Enceladus with their subsurface oceans that might harbor life.
Right.
We've got volcanic moons like Io spewing out plumes of sulfur. And we've got Titan with its thick atmosphere and methane lakes.
So it's like a whole buffet of moon possibilities.
Exactly. And the great thing about exploring new worlds is that we often find things we never could have imagined. You know, before we sent probes to the outer solar system, we had no idea that moons could be so diverse and dynamic.
So if Planet X does have moons, they could be even weirder and more wonderful than anything we've seen before.
Absolutely. I mean, just imagine a moon with a nitrogen atmosphere so thick that it rains liquid methane, or a moon covered in volcanoes that erupt with ice instead of lava,
Wow.
or a moon with a subsurface ocean that's heated by tidal forces, creating hydrothermal vents that could support life.
Okay, now you're really getting my imagination fired up. But let's bring it back down to Earth for a moment.
Okay.
What are the chances that we'll actually find any of these hypothetical moons?
Well, that depends on a few factors, including the size and reflectivity of the moons, the sensitivity of our telescopes, and a bit of luck.
So it's a long shot, but not impossible.
Exactly. And remember, even if we don't find any moons right away, the discovery of Planet X itself would be a huge accomplishment. It would open up a whole new avenue of research, and it would inspire a generation of scientists to keep exploring the outer reaches of our solar system.
And who knows what other mysteries they might uncover along the way. Maybe they'll find evidence of another even more distant planet out there. Or maybe they'll discover a whole new class of objects that we haven't even imagined yet.
The universe is full of surprises, and that's what makes it so endlessly fascinating.
Yeah.
You know, as we're talking about all these exciting possibilities, it's important to remember that science is a process of careful observation, rigorous analysis, and constant questioning.
Meaning?
Well, even though this research presents a strong case for the existence of Planet X, it's still just a hypothesis. We need more data, more observations, and more independent verification before we can say for sure that it's out there.
So we need to be cautiously optimistic.
Exactly. We should be excited about the possibilities, but we should also be prepared to revise our theories if the evidence doesn't support them.
It's like you said earlier, science is a journey, not a destination. And this search for Planet X is just one chapter in that ongoing journey.
Well said. And it's a journey that we're all on together. Every new discovery, every new piece of evidence brings us one step closer to understanding our place in the universe.
And that's what makes it so exciting.
Right.
The knowledge that there's always more to learn, always more to explore, always more to discover.
Absolutely. And to you, our listener, we hope this deep dive has sparked your curiosity and inspired you to keep looking up at the night sky, wondering what other secrets might be hidden out there among the stars.
Because as we've learned today, even in our own solar system, there are still vast uncharted territories waiting to be explored. Who knows what wonders we might find if we just keep looking.
Until next time, keep questioning, keep exploring, and never stop being curious about the universe around us.
Thanks for joining us on this deep dive into the orbit of a possible Planet X. We'll catch you next time for another fascinating journey into the world of science and discovery.